Good evening, fellows from the Philippines. So welcome to the PIChE UAE chapter technical webinar. Before I introduce to you the speaker of the technical webinar, here are the points or the webinar guidelines for us to follow in the middle of the talk. So first, guideline: all participants except for the facilitator and speakers will remain muted throughout the webinar. So second, type in your questions in the chat box anytime during or after the presentation. Questions will be entertained during the open forum. Only when necessary, unmute your mic to speak up. So third, occasionally, polls will be launched. Everyone is encouraged to get engaged. So fourth, for any assistance, please direct your message to the host or moderator through the chat box. So everything is clear now
Yes.
for the webinar guidelines. If you have questions for the guidelines, you can you speak. So I think there's none. So let's now proceed. Okay, to continue to introduce to you our speaker of our technical webinar with theme Operational Excellence, the Steps of Autonomous Maintenance. Here is his brief background. So he is a graduate of Adamson University of batch 2006. Also at the same year, he got his license. So he's a licensed chemical engineer in the same year. And third, he is a certified process Kaizen engineer. He is also a certified AIB International Food Safety and Food Defense Coordinator, a former president of PIChE Pampanga, and a former associate engineer of Saudi Arabia Council of Engineers.
Okay. And to give us also a brief of his work experience, he was a former manufacturing excellence production manager in Ubaykan Ilupak, Riyadh, in the Kingdom of Saudi Arabia. He was also a former process engineer in Trust International Paper Corporation, and he was also a faculty member in Holy Angel University College of Engineering. And mind you, Jerwin, he received a lot of awards from LED Elupak in winning the Obican Manufacturing Excellence Flagship Plant Award in year 2018. And he was also a top-notcher and a fiscal process Kaizen engineer for quality in year 2017. He was a bronze medalist in Kipner-Trigo International Rational Thinking Process for this Achievement Award in year 2014. Please help me welcome Engineer Joseph Rafael.
Wow. Good day, everyone. And thank you for that lavish introduction. 2 weeks ago, Engineer Enrico asked me to be the speaker for this webinar, and I gave him 10 topics. And interestingly, you guys chose autonomous maintenance. Is it because we are approaching Industry 4.0 and the autonomous vehicles is rising with its popularity? But sorry guys, I will not be talking about rocket science here. I will be dealing with the small things that are often neglected on a manufacturing plant. So what I will be discussing is about operational excellence, and I will give you the best practices and tips in implementing autonomous management or maintenance. I had difficulty in streamlining my slides, to 1 hour, because normally for the entire session of operational excellence, wherein I have to deal or to discuss all the steps and the corresponding activities of AM, it will take 2 days. But I think uh, we can get over on this. And if the BODs of PIChE said, uh, we have a question and answer portion later. So just chat in your inquiries. And if you have any questions that I won't be able to answer, you can email me at jmrafael.work@gmail.com, or you may connect with me through LinkedIn. For this session, I will be discussing operational excellence, just an overview of this, and then autonomous maintenance, and what's the definition and the purpose of this important pillar in operational excellence, and then later the steps of autonomous management, including the best practices and tips in implementing it. For my 13 years of experience in manufacturing, I had the privilege to have an extensive experience in terms of various management systems and continuous improvement programs. It propelled me to my career progression, actually. In 2013, all of these things that you can see on the screen, we implemented it in Obeikan Alopak in Riyadh. For 2 years, we had a lot of savings. We did a lot of improvements. We were recognized globally, as well as we are considered as the number one in terms of producing liquid packaging in the region. However, in our 2015 strategic planning, we felt that although we are strong on this continuous improvement tools, we can still be better. There is an opportunity that we can still be better. And to back that up, we still have 13 million Saudi riyals losses in the plant. Apart from that, the continuous improvements were just done by few people, the process engineers, the team leaders, and the quality management system representative. And for us to maintain our competitive edge, we put in our strategic plan to have an operational excellence program which will link all our previous learnings in terms of continuous improvement and further propel our company and ensure that we are still the number one in the market. So that operational excellence program is the missing piece in the puzzle. Operational excellence is defined as a philosophy that embraces problem solving and leadership as a key to continuous improvement. It comes in many names: continuous improvement, total productive maintenance, business excellence, Lean Sigma and lean manufacturing, or world-class operations management. But they're all the same. They should not be taken just a flavor of the month because it's a fad in manufacturing. It should be able to sustain your continuous improvement program to greater heights. Now, the goals of operational excellence program are this: delighting the customers, achieve world-class results, and cultivate a culture of innovation and Kaizen. Delight the customers is more than satisfying the customers, because if you did that, it will return tenfold. How about achieving world-class results? Say an 85% machine efficiency, or achieving a 99% on-time in full delivery of your products, or reaching 2 million safe man hours, or reducing your customer complaints by 80%. Or how about saving or cutting that losses by 50%, resulting to around 6 million Saudi riyals. I did not invent those figures. Those are the actual figures that we got when we implemented operational excellence program in my previous company in Riyadh for the period of 3 years. Operational excellence aims to cultivate a culture of innovation and Kaizen. Now, what's the difference between the two? Kaizen and innovation are both improvements, but they differ in terms of effect, cost, risk, and effort. And both of them are essential in order to achieve your vision in zeroing out the losses and involving 100% of your people. It sounds very ideal, right? But you have to aim higher. You have to aim for the top, and you should not lower your standards when it comes to operational excellence. Now, on your company, do you practice an operational excellence or continuous improvement program? If yes, you can type in A if it is fully implemented, B if it is partially implemented, and C if not at all. Okay. So I hope most of the answers are in A and B. But if your company is still at the level C, it's time for you to highlight this or introduce this to your managers, to your bosses. And who knows, it might be a game changer on your career. Moving on, an operational excellence program has different elements. On my previous company, we had 6 elements and 7 pillars. Those elements are dealing with organizational development. When we say organizational development, it is about measuring the culture change in the company. Okay, what is the level of engagement of the people? And how are the people performing in terms of operational excellence? Results and control are also very important. We are doing operational excellence because we have a vision and we want to attain it. Moreover, when you implement an operational excellence program, it costs a lot of money. So the benefit out of the program should outweigh the cost by around 400%. So that's the aim for operational excellence program. Also in operational excellence, the improvement teams may be Kaizen, which are the little improvements, or innovation, which is the big improvement, should be measured and should be ensured its effectiveness, and the composition of the teams must not just be for a few persons. The team composition should be uh, diverse and cross-functional. Right? The last pillar under element under operational excellence is the pillars management, wherein all the know-how and standards and the how-tos for solving an issue is under this. Now, we have I discussed the 6 pillars of operational excellence, and we have 7 pillars for this. As I've said, one of the element of OpEx, which is pillars management, aims to attack a specific loss. Each pillar, by the way, the pillar composition depends on the needs of the organization. Each pillar has their own loss to attack and their specific methodology to use in order to eradicate that loss. For example, quality management. They are the pillar for they are the pillar that is dealing with the losses in terms of materials, say scraps, rejects, overusage of materials, and usually this costs a lot in the structure of cost of the company. 40 to 60% of the cost structure of the company usually is coming from materials. Now, losses are part of the operations, right? And wastage are inevitable. So the aim of this quality management pillar is to reduce the material losses into an acceptable level to be as minimum as possible using methodologies such as process scrap reduction, quality defect reduction, or overusage reduction. Now the same goes with the other pillars. They have specific laws to attack and they have specific methodologies to use, except for the autonomous maintenance. Autonomous maintenance, or in Japanese, they call it Jishu Hosen, or in other, they call it autonomous management, is a unique pillar because they are not directly attacking a specific type of loss. They are dealing with the small issues and they are dealing with the improvement of the behavior and the competency level of man, which are the operators. Now, what can you say about this work environment of this condition? Oh, it's so dirty, grimy. Do you want to work here? No, it's if you don't have a choice, then you have to work here, right? So when you get involved in an organization like this, at first glance, oh, my work environment is so dirty, I don't want to work on it. But if you have no choice but to work on that, your standards will be tailored to what is around you. If you are in an organization that is composed of incompetent individuals, and even if the organization is so fucked up, you tend to tailor your standards on that, and it becomes your new normal. In operational excellence, we don't want that because we care about the image of the organization. We care about the image of the organization for the customers, for the visitors, for the stakeholders, but more importantly, for the employees. Okay. I had this experience before. We don't have this kind of program wherein during audits, we tend to spend lots of man hours in cleaning the machine, in cleaning the floors, in making sure that the route that the visitors will be taking in the factory are well maintained or shining clean. That's not the essence of operational excellence. And when you have when you properly deploy autonomous maintenance, autonomous management under operational excellence, any visitors can visit your plant anytime and the condition would be the same. And as I've said, the image of the organization should not just be for the VIPs, but more importantly to the employees, because the work environment affects their way of thinking, affects their mood, affects their excellence, affects their pride. AM, or autonomous maintenance, changes people and machine. So in AM, it always takes two to tango. It's like walking, you know. Okay. If, for example, you purchased a new machine with the latest technology, and then the people, you did not invest anything for their competency level, what will happen to the machine? It will deteriorate, right? What if you invested a lot in terms of closing the gap on the competency level of your employees, but then you are neglecting your old machines. You are not fixing the request of your people to make it easier to use, to maintain, then it will not happen. Your continuous improvement aim will not come to fruition. So in AM, it always takes two ways: improvement of the people and machine. Autonomous maintenance is a system to restore machine basic condition and to equip operators the necessary skills and attitude to maintain machine independently. So that is the key word, independently. In AM, we are educating operators while they are restoring and improving their own machine. By doing this, they develop their sense of ownership, and slowly they are changing their behaviors and paradigm. Okay? In a traditional factory or manufacturing world, there is a silo between departments. I am an operator. I will just operate the machine. If a machine breaks down, I will call the maintenance people, okay, and I will just stay back, watch him, cheerlead, or say, Inshallah, bukra, the machine will be okay. Okay. In an operational excellence world, in implementing autonomous maintenance, the role of the operator changes. He will say, I operate the machine and I help maintain the machine. And in the future, when you implement AM, you will develop a world-class factory like the ones like those blue chip companies such as Pirelli, Danone, Nestle, PNG. They all follow an operational excellence program. Another thing, although I said a while ago that autonomous maintenance does not directly attack a loss, except apart from losses related to lack of cleaning and lack of organization, they help improve the machine efficiency or overall equipment effectiveness, reduce breakdown, reduce short stoppage, and reduce defects. In implementing autonomous maintenance, it will take 7 steps from initial cleaning and until the operators have that autonomous Kaizen thinking. Okay? And on each step, there are lots of activities to execute. And when we first implemented this program in 2015, this specific pillar only, autonomous maintenance, we choked. We choked because what we did is to implement the 7 steps to all the areas in the plant. But that should not be the case in implementing autonomous maintenance in a factory, in a manufacturing company. It should be like eating an elephant. How do you eat an elephant, by the way? The winner will get an elephant stuffed toy from the president of PIChE UAE, Hilbert. Just joking. In implementing operational excellence and autonomous maintenance, or when you are dealing with a big issue, or when you are aiming for or envisioning a big target in your life, eat eat one bite at a time. So meaning one step at a time, one little improvement at a time. That's how you attack an operational excellence autonomous maintenance approach so that you can properly chew and the nutrients will get to your body and to your heart and to your brains. But guys, elephants are not really eaten. Anyway, moving on to the steps of AM. As I've said, I won't be able to tackle all the activities under each step. I will just give you the highlights and the best practices when implementing these steps of AM. The first step is initial cleaning. In initial cleaning, in terms of machine improvement, we want to eradicate machine losses due to poor cleaning. Okay? Those areas, those deep areas that were not cleaned for so many years, clean it, or else it might result to a bigger issue. This morning, uh, my mother-in-law is cleaning uh, cleaning a room in the house, and our house helper found a small snake. So yes. So just if we continue to not touch those areas or rooms in your house or in your machine, it might create a bigger problem, a more relevant problem in the future. So in terms of man improvement, as I've said, in AM, it's always machine and man. In terms of man, operators learn to spot small issues and correct them before they become bigger. In initial cleaning, the step 1 of AM, I highlighted here 3 major activities: planning and preparation, tagging and detagging, and total cleanout process. In planning and preparation, this is important not just actually in step number 1, but on all steps of autonomous maintenance, as well as on various improvement programs, or when you are dealing with calamities or pandemic. So plan is very important. Okay, you need to know who will do what and where, what specific area are you going to tackle, when will it be, what are the resources needed, who will be involved, and how are you going to execute it. Because if you fail to plan, you plan to fail. So planning in every improvement is important. Okay. Next thing is tagging and detagging. Tagging is sort of an information to highlight the abnormalities in the machine. Take a look at these photos on the left and on the right. What can you say? Okay, so the right photo on your screen looks dirtier and it's like a Christmas tree. So we know that there are lots of defects there, right? How about on the light on the right side, on the left side of your screen? So maybe there are no defects. Maybe there are defects underneath or on the side or on the top. We don't know because we did not visualize those small things, those wrong things on the machine. So that is an example. This is an example of a tag that that I developed. Right? It lists types of small abnormalities in the machine, such as unsafe condition, lack of cleaning, lack of lubrication, missing parts, leaks, unorganized items, hard to reach areas. If you are not able to spot those small things or highlight those small things, as I've said, it might yield to a bigger problem. 10 years ago, when I was in a paper mill, I remembered a time when one bolt generated more than 1 million of losses. Okay? The machine has vibration, of course, and the bolt is not tightened. It's loosened. So it went to the for dryer machine, and eventually it damaged some rolls, some important parts of the machine, wire or mesh clothing, which is worth 1 million, and generated lots of waste. So that's so those small things on your machine, on your house, on your work areas, do not take that for granted. Okay. Now, after planning, and you already have a system on how to tag and detag, the next process is the total clean out of your machine. It is an activity involving all the operators plus the support group and the management team in tagging and detagging as well as in cleaning the machine. So it is essential that the managers, the supervisors, and team leaders are there when they look for the small abnormalities in the machine as well as in cleaning. Because if you do that, the operators will feel that you are serious about this program. Okay? And the effect on the operators, if they do a total clean out process wherein all the portions, those hard to reach, the top, the bottom, the side, the insides of the machines are cleaned, they will feel that it's very difficult to do this, right? And I don't want to to regress again on that type of scenario. A good best practice when you do step number 1 of AM is to document your before and after photos, such as this. Okay, and that after photo will become your new standards, your new normal. Okay. Also, it is important to register and analyze all your tags. Do a Pareto chart of your types of tags, and then you can classify your detagging in terms of priority. And also, you should communicate the results of your tag removal to your employees, to your operators. What happens if you did not communicate, or you are taking for granted whatever they have written on the tag? Okay, they will feel that what they are doing is not important. So it is essential to tag for the operators to remove that, and also it's equally essential, equally important to remove those tags. So that is step number 1 of autonomous maintenance. Moving on to step number 2, we have elimination of sources of dirt and hard to clean and inspect or hard to reach areas. Now, the improvement in terms of machine under this step is to reduce cleaning time and make equipment easier to inspect. For the operator side, they are starting to understand the importance of no dirt and to know how to inspect simple parts of the machine in an easy way. So for step number 2, the highlights are mapping and analyzing your dirt sources and those that are hard to reach, and implement or suggest solutions in order to improve that. As they say, you cannot improve what you do not know. So it is key to map and quantify your dirt sources. And then it will be your guide on what parts of the machine or dirt source are you going to prioritize. For example, in this printing line, we identified around 75 sources of dirt. Also, in terms of hard to clean or hard to inspect areas, you should also map it. All the areas of the machine that are effortful to clean and inspect, wherein you need to stretch out or climb, or not really convenient to go to, map it. And then analyze what are the reasons why you are experiencing that dirt. What are the reasons why it is hard to reach? So from mapping and From mapping the sources of dirt, you analyze it, and then implement solutions. In thinking solutions for dirt sources, you should think this way. Eliminate the source. Okay, can I eliminate the source? If not, can we contain or reduce the dirt source? If not, can we make it easier to clean? Or can we just protect the critical components of the machine? So always think for elimination, then go to the lower level. These are examples, right? On the left photo, the before photo, you can see that there are lots of scraps here and particles, and the operators tend to go clean this part of the machine 4 times in a shift. So what they did here is to install a vacuum, and they totally eliminated that cleaning. These cables, okay, lots of unused cables on this photo. And then when they removed all those unnecessary items, it becomes easier to inspect. It becomes easier to see if the area is clean or not. Okay. Now, step number 2, as I've said, aims to reduce the cleaning time spent by operators on the machine. We don't want them to spare 50% of their time cleaning the machine. So that's why in step number 2, we want to reduce it significantly. Why do you think that's the case? Usually for step number 2, we spend ideally in step number 2, but it depends on the size of the machine. It will take 6 months for this step alone, up to 1 year. Okay. The reason why we want to reduce the time spent by operators in cleaning the machine is because there are other steps of AM. There are 5 more steps of AM, and we cannot saturate the load of the operators, or else they will choke. They will not handle it. They cannot handle it. Now, moving on for the step 3 of autonomous maintenance, it's creation and maintaining a cleaning, inspection, and lubrication standards. So in step number 3, we are now completing the famous CIL, which is the key in the restoration of basic machine condition. Now for the man, we are starting to give some maintenance activities to the operators, in particular lubrication. Don't get me wrong, we don't want to transfer all the lubrication activities to the operators, because that will take a lot of skill, and the operators will not have enough time to do those lubrication activities. Just those basic lubrication that they can easily do to alleviate some tasks from the maintenance personnel. Now, under step 3, we have 2 activities: study and improve the lubrication, and then train the operators on lubrication. At this stage, the twin pillars of planned maintenance and autonomous maintenance, which is the AM and PM, they can convene for a joint activity in order to study, to plot the current lubrication system. They first, of course, they know what they want. They first plotted what they want to improve. So they map the lubrication system and then study the current process of how they do things, the lubricants they used, and the tools that they are utilizing for the execution of lubrication. Now, after identifying the current state, we can implement an EZRS approach. EZRS means eliminate, combine, rearrange, and simplify. Are there any unnecessary activities or waste of movement over processing or waste of materials in the lubrication system? Are we sure that there are no repetitive points to lubricate? Is it correct that this lubrication point should be lubricated twice a day, something like that? Or can we make it just a weekly lubrication for this point? So we are eliminating some tasks or combining some tasks or rearranging some tasks. And if possible, can we automate the current lubrication system? So that's how you think when in terms of improving the lubrication system. Then after which, train the operators on the system, on the newly improved system in the classroom for them to know the theory why lubrication is important, and more importantly, actual training on the shop floor together with their coaches, the maintenance guys. Any questions so far at this stage? You can type in the chat box. So we already covered the 3 steps of AM. The first one is initial cleaning, elimination of sources of dirt and hard to clean and inspect areas, and then creation and maintaining a CIL, cleaning, inspection, lubrication standards. Now, jumping from step 3 to the higher step of AM is a change in terms of the mindset of the operators. For the first 3 steps of AM, we are changing their behavior. On the higher steps, we are changing the competency level of the operators. Now, in terms of man, in steps 1 to 3, we are dealing with the restoration of basic machine condition. Now, in steps 4 to 7, we want to further improve and reduce the losses on the machine. Now, for steps 4 to 7, I will just highlight the important activities. In step number 4, which is general inspection, we start to promote visual management. Okay? We want the machine to talk to us, to talk to the operators, such as this. Okay? Can you see the machine talking? Can you hear him? Hey, Sadiq, I am on green. Keep it up. Mukmafi, Sadiq, you are in red. Adjust me. Or you need to clean me every hour on this point. So that's what we say. That's what the machine says to the operators. And it's easy because it is color coded and it's visually enticing. Okay, another thing in step number 4, as I've said, we are increasing or closing the competency gap for the operators is for them to have a technical training room. A technical training room which is not just a classroom, but also includes this practical training materials for the operators to better understand the mechanism of the components of their machines. Okay. Now, step 5, it's autonomous inspection. At this juncture, the autonomous management pillar and the quality management together join towards one goal, which is identification and integrating the quality points on the checklist of the operators, on the inspection checklist of the operators. Now, what are these Q points? These Q points or quality points are the critical components on the machine that, if not maintained properly, will result to a quality issue. This is an example, right? We integrated in the CIL checks, okay, quality checks, safety checks, tightening checks, making your CILSQT. Okay. Now, moving on to step number 6 is area standardization. Since at this stage, the operators are already competent enough and knows much of their machine, they can do they can solve the issues in the machine on their machines independently, okay? Even without the guidance of the engineers and the team leaders and the supervisors. So when they encounter an anomaly or abnormality in the machine, right, they use this simple approach. Do a fishbone, do a 5-why analysis, and then report it to your superior. So that's uh, step number 6, area standardization. Apart from that, we are empowering the operators to create their own standards, okay? Write their own 1-point lessons. Okay? Since at this stage we have lots of documentations already, uh, it's also important to involve the digitalization committee on digitizing your forms and reporting system. This is an example of what we did in my previous company. The SOP we issued them uh, tablets. So for each machine, there is a tablet. And if they want to check and they want to conduct CIL checks. So they just scan the QR code and they will be directed to the portal. Or also for the 1-point lessons or the SOPs, right? They don't have, so we don't have to put a manual copy on the floor, which sometimes they need to walk because it's very far. So they just need to scan it and then the guidelines are there. So in step number 6, digitalization is also important. Okay. Now on step number 7, which is the final stage of autonomous maintenance, is called autonomous Kaizen. Okay. As I've said, it will take years before the level of operator becomes this. In a small factory, it will take 5 years, but for a bigger one, it will take 10 years. It all depends on the qualification of the operators and the competency gaps that they have. Now, on step number 7, they are autonomously implementing Kaizen. Kaizen is the word for continuous improvement, those small improvements. So it is a best practice to introduce an employee suggestion program under this step. Okay, but take note, when you are doing this suggestion program, it should not be the common that we see, right? There is a drop box in the company lobby, but nobody is writing anything. Okay? It should be properly institutionalized with a rewards system and linked to the performance of the employees so that your employee suggestion program will become successful. And lastly, for step number 7 is improving the performance control system. Okay. How are the operators tracking the performance of their machine on an hourly basis, on a per shift basis, on a weekly basis, so that by the end of the year, they are not clueless why they have reds on their key performance indicators or why they achieved all green on their key performance indicators. Now, we covered the 7 steps of autonomous maintenance. We have initial cleaning, elimination of sources of dirt and hard to inspect and clean areas, creation and maintaining a CIL or cleaning inspection and lubrication standards, general inspection as step number 4. Step number 5 is autonomous inspection, standardization for step number 6. And the final step of AM is autonomous Kaizen. In AM, we do a simultaneous development of people and machine. There are 7 steps to accomplish that, but as I've said, take it one step at a time so that you can reap the fruits out of this beautiful operational excellence program. Thank you so much. Now I am open for your questions.
Okay, thank you very much, Sir Joseph. We encourage everyone, all our participants, to raise their questions. They can type it on the chat box, and they can also raise up if they wanted to speak out. Okay. So we encourage them to ask questions. This is the right time. It could be a help for all of us in our operations area. So, sir, first question I have here from Sir Hilbert. If an operator can work independently, following autonomous Kaizen thinking, thus a full accountability of any mishaps deter such change in behavior. And how do you deal with this?
Can you repeat the question, Rebecca?
If an operator can work independently, following autonomous Kaizen thinking, thus a full accountability of any mishaps deter such change in behavior. How do you deal with this?
Okay. There is an element in operational excellence. It's called performance control system. In performance control system, we are clearly identifying the responsibility, accountability, who's consulted, and who's informed in every activity. Now, if at that stage of the implementation of operational excellence or autonomous Kaizen thinking, wherein the operators are already independently doing their, say, CIL activities or independently doing some maintenance tasks, then they are accountable on that. If in case there are mishaps, then you should know how to deal with that. For example, just like in any organization, if there are some what do you call that? If there are mishaps or issues or wrong things, you know how to deal with that, right? So did I answer you, Hilbert?
Yes, sir.
Okay.
Okay, sir. In to follow up that question also, sir, how we can differentiate the the responsibility and accountability of the operators and from the maintenance or engineering department?
Yeah. Okay. That's a good question. That's why in operational excellence there is a performance control system element which deals with the distinction between the responsibility and accountability of operators. In under responsibility, you know, in our structure of operational excellence, there can be more than one responsible for a specific task or specific key performance indicator, but there should only be one accountable for a specific KPI. For example, uh, machine speed. The machine speed is being controlled by the operator. So he is accountable on that. He decides, he knows what to adjust and what is his decision in terms of the speed. Maintaining the critical component of electrical parts. So usually we cannot just give those things to the operators because it takes kind of specialization in order for him to uh, for a person to have that to perform that task. So that is the accountability of the maintenance personnel. So having a clear RASI chart will solve the issue in terms of who is responsible to what and when and where.
Okay, thank you very much, sir. Another question from Sir Enrico. How to implement AM in a highly diverse organization in terms of nationality,
Mhm.
cultures, belief, and etc.
That's a very good question. Question. When I was in Riyadh, I was a production manager of more than 100 people, and came from they came from more than 10 countries. So it's very diverse, employees. So what we did when we implement operational excellence, when we did AM, is to communicate with them, to bombard them with communication. We have SOPs in various language. Okay, we have trainers in that can speak different language. So, and we have posters that communication posters and videos that doesn't need for them to hear or to read what is in the poster, but just by seeing it they can feel the message of the poster already. Communication is key in terms of operational excellence, specifically autonomous maintenance, especially for those who are in the who has a diverse team, just like you guys in the Middle East.
Okay, thank you very much, sir. Okay. Another question here from Engineer Florencio. Autonomous maintenance is uh, really a good program which is similar to operations driven reliability. The
Mhm.
most challenging part is the sustainability of AM program. Have you
Yes,
encountered this challenge as well? What do you
yes.
think is the most significant factor to sustainable AM program?
Okay. So in terms of implementing operational excellence or AM, at the beginning, people are excited. They are excited to learn about this new thing. But as the years go by, there are times that the engagement of the people deteriorates. So what we did on that is to explain to them what is the benefit of this program on them. I told them, if be selfish in learning AM, because you never know how long you will stay in this company. And also, if you perform autonomous maintenance and we are able to save lots of money and we perform or we hit our targets, then at the end of the year, you have what? Bonus. So we link it to their performance control system. And if they are hitting their performance, then it will reflect on their adjustments. It will reflect on their bonuses.
Okay. Okay, thank you for that one, sir. Another question here, sir, from Jesse De Guzman. Following the question of Sir Enrico, how do we engage senior operator or operators
Mm-hmm.
adapt to AM? Is there
Mm-hmm.
any steps in engagement?
Yes, that's another good question. I like the set of questions you are throwing, Rebecca. Uh, for the engagement of people, we have another element for that in operational excellence. It's called organization and change management, which is measuring the level of engagement of the people for a program. Now, what are we going to do to keep them engaged? As I've said a while ago, link it to their performance and always encourage something new, communicate with them. So that is important.
Okay, so thank you very much, sir. Another question here. In an operation where most processes are carried out by autonomous machines, are
Mhm.
these distinct EM steps apart from those presented earlier?
Mhm. Are there any distinct
Distinct EM
steps
steps
for
from
that?
those present, yes, sir.
Mhm. You can apply also the steps of this AM, but you may omit other activities. Okay.
Okay,
You can
thank you,
jump
sir.
on other steps, or each step actually has 5 or 6 or 10 activities to follow. So you may omit uh, those that are not um, applicable on the machine, especially to those high-end machines that are run by robots.
Thank you, sir. Another question here, sir. Is AM applies to any kind of manufacturing plant, and what's the relationship of AM to Lean Six Sigma?
Okay, so autonomous manufacturing
Sir Joseph, are you still there, sir?
Mukhang na-disconnect si Joseph.
I think there's something wrong with the network niya, sir.
Yes. Anyway, while waiting for him, I think we'll take in few questions before we end. But I think I have shared the results of the poll. So it's nice to know that only a few of the attendees know autonomous maintenance. Uh, and second question, I think most of you are working in companies where you are partially implementing autonomous maintenance. And last poll, okay, I think majority got the correct answer. So basically, test ito kung nakikinig kayo. So yung last option dito yung correct answer sa third poll. So steps 4 and 5, which involves general inspection and autonomous inspection, would improve or maintain optimal conditions of machine and improve the competence of the people. Yung first one, yung steps 1 to 3, that would restore the basic conditions of the machine and change the attitude of the people. Okay. Let me check. Wala pa rin si Joseph. So, I think I think one
Hi,
of our members, nandiyan na ba si Joseph? Wala pa.
andito na.
Nandito na. Okay, sir. Welcome back, sir.
Okay.
Sorry,
Welcome back.
nag-connect ako sa ibang Wi-Fi.
Okay.
Connect ako.
All right. Go ahead,
Yes.
Becky, sir.
Okay, shall I repeat the question, sir?
Oo, nakalimutan ko na.
Okay, sir. Is AM applies to any kind of manufacturing plant, and what's the relationship of AM to Lean Six Sigma?
Okay. So AM can be applied on all types of manufacturing. When I was in the Obican Investment Group, we have plants not just for packaging, but also for paper industry, which is a very big plant for glass manufacturing. Okay, and even in other types of industries. So it's applicable to all types of manufacturing. Now, what is the relationship of AM with Lean Sigma? Now,
Yes.
if you do lean manufacturing or lean sigma, you have to improve on something, right? You are dealing with specific type of loss. Now, those are usually done by the belters, the white belters, the green belters, and the improvement that they will identify on the machine will be transferred to the autonomous maintenance or the operators. So that is the link between the improvement programs done by Lean Six Sigma or Lean manufacturing experts to the autonomous management PIPs or operators.
All right. So thank you for that answer, sir. So another question here, sir, from Ruby. Is there a global standard for AM?
Global standard for AM. The steps of AM is the same. We follow the checklist in terms of operational excellence, and we are being audited on a quarterly basis for that. So I think other consultancy firm they have this checklist, but there is no. I don't think that there is a global standard such as ISO related to autonomous maintenance. But the concept, you can find it similar.
But sometimes, sir, if a company is implementing the good manufacturing practice,
Yep.
it can sometimes be audited.
Yes.
Okay.
Yes. Actually, if you implement AM, it's like implementing good manufacturing practices too, because it
Exactly,
deals
sir.
about cleaning, it deals about inspecting the machine, maintaining the critical components, the quality points, or the safety.
Yes, sir. That's right, sir. Thank you for that one, sir. And another question here, sir. I have one last question from this list. How long
Mhm.
is the typical ROI for implementing a AM program?
As I've said a while ago, the autonomous maintenance pillar is not directly attacking a loss. Those are the tasks of the quality, the planned maintenance, but AM helps in ensuring that the improvement programs that improvement plans or the improvement projects that the other pillars did are implemented. So at the first few years of AM, when we implemented in my previous company in Riyadh, we are not accounting for the ROI of AM because we cannot account the say the losses for cleaning. It's quite difficult, but we are ensuring that we are linking whatever activities of AM to each key performance indicator. But to normally for the overall operational excellence program, during its first year of implementation, uh, we have around say on the first year of implementation we had around 600,000, no, we had around a million of reals savings versus 500,000 of investment. So in the span of 4 years we are able to 3 years rather, we are able to hit 6 million savings versus 1.5 million uh, investment for the program. So when you are already at the world class level, it should be 4 times your benefit should be 4 times your cost or investment.
Okay, so thank you very much, Sir Joseph. I think I don't receive any questions now. Okay, thank you very much for a very comprehensive information that we have learned from you, sir. It's a big help for us, especially to those who are working in an operation field.
Mm-hmm.
So it's a big learning for us, sir. And before we will end up this technical webinar, may I call on Engineer Marilyn Tabasan for the awarding of certificate for our speaker for today.
Good evening, everyone.
Thank you, Engineer Joseph, for that fruitful and substantial talk. We will surely implement the 7 steps of AM in our company, and I'm sure that our bosses will be great to hear about this.
If you have any questions, just email me or connect with me via LinkedIn.
Okay, sir. Thank you once again. So, for closing remarks, may we call on Engineer Aldrin Castro, the Vice President for Dubai, for closing remarks.
Thank you, Mr. Jerwin El Chico. So, good evening, everyone. Good afternoon for our UAE members. Thank you for those who have attended, especially yung mga UAE members natin na mula pa kanina nakakonect na. Thank you very much for your attention and for your time na binigay nyo sa ating organization. And thank you, Engineer Joseph, for your very comprehensive and
You're
wonderful
welcome.
talk about OPEX. We enjoyed it, and I think everybody got their own fair share of knowledge on this one. And all I can say is napaka-successful ng GA natin, considering it's a webinar GA. It's a first for our organization. I think it's
Wow.
also a first
Congrats.
sa karamihan. And sa mga kasama nating PIChE members from the Philippines, thank you again for sharing your time. Although gabi na dyan, and I think it's dinner time for you guys. Hope you got your information for this webinar. And we hope to see you on our future webinars, not only for the CHU week itself, but for the upcoming webinars na pinaplano ng organization namin, which we will share definitely sa inyong lahat. And once again, thank you for the organization body. Thank you for the Dubai team, kay President Engineer Hilbert Libres, Sir Enrico. Salamat po sa inyong mga sponsorship, Ma'am Eileen, and kay Marce, na nauna na sa atin. Salamat sa inyong mabuting puso. And sana nag-enjoy yung mga naglaro kanina sa ating quiz contest. Hope we can make it a nice staple for our future programs pa. And with that, I bid you all thank you, goodbye, and have a nice day.